30-1s. Here is a quick lesson on tangent graphs. Now, compared to sine and cosine graphs, we don't have to do as much with a tangent graph in 30-1. Now, recall where we got the sine and cosine graphs from. We got them by just simply looking at the unit circle. So I'm going to do the same thing here. All we really need to remember is that tangent is sine theta over cos theta. Or on our unit circle, that's us. We're going to go around and we're going to go y divided by x. Okay, that's tangent. So let's do that. Now, what I'm going to do to speed it up a little is I'm actually not going to look at every single point. I'm going to start here. Well, 0 divided by 1 is 0. There we go. I'm going to skip over to pi. 0 divided by -1 is 0. I come back to 2 pi. 0 divided by 1 is 0. Now what I'm going to do is I'm going to go look at pi half and 3 pi half. Well, 1 divided by 0 and -1 divided by 0, well, anything divided by 0 is undefined. If you recall back, when we divide by 0, graphically what that'll do is that'll give us vertical asymptotes, just like that. And we'll also have a vertical asymptote at -pi half. All right, so what we've done so far is we found the theta intercepts and we found these vertical asymptotes. Now what I'll do is I'm going to skip over pi 6 and pi 3. I'm going to look at pi quarter and 3 pi quarter and 5 pi quarter and 7 pi quarter. Well, why am I looking at those? Well, if you notice, when we divide y divided by x there, we're going to get 1. So at pi quarter, we're going to be about here. And at -pi quarter, I'd have -1. So what is this graph going to look like? Well, without drawing the rest of the points, which we could, but we don't really need to, this is what this graph is going to look like. Interesting, isn't it? And here's what the rest of our points would all look like. That's kind of a neat looking graph. So when you're looking at these graphs, sometimes our graphing calculator doesn't do the best job, and I'll show you that in just a moment. Okay, there is a tangent graph. So the basics that I need you to know. Okay, what I really need you to know. For sure, I need you to know the period. Okay, the period is the distance between my intercepts, is pi. Or I could also say it's the distance between my asymptotes, which is also pi, or 180 degrees. If you think back to this little formula that we use for sine and cosine, well, we need to adjust it now. It's not going to be 2 pi, because that's the period of sine or cosine. It's simply for us in tangent going to be 1 pi, or 180 divided by b. Okay, there's your period. Your range. Well, your range isn't going to be that important in terms of a question on a test, because look at your range. It's going to be infinite in both directions. Okay, the better questions and the more important part is the domain and the equation of the asymptotes. So our domain here, well, theta such that. Now, theta is an element of the reals, except for theta can't equal where all these asymptotes are. Well, our first positive asymptote's at pi half, and the distance between any asymptote is pi. So some multiple of pi. So n pi, pi n, however you wish to write it, comma, n is a member of the integers. That's it. Okay, there's your domain. Your asymptotes then, well, if you know your domain, then you know your asymptotes. Your asymptotes are theta equals, because it's a line, pi n or n pi again, and a member of the integer. There's the equations of your asymptotes. Now, what does this look like in my graphing calculator? Let's take a peek. So let's go ahead and let's graph this. So just graph tan x. And I'm just going to go back to zoom, and I'm going to go zoom trig, and you can take a peek at what it gives us. It does an okay job. If you have a TI-83, some of the TI-83s would draw those vertical asymptotes in, which make it a little complicated for us to see what's happening. But there it is, friends. There is the graph of a tangent function. Hope that was helpful.